Hello friends. So today we are going to see the power screws. So power screws, as the name suggests, it is used to transmit the power. It is used to transmit the power. As we know, the nut and bolts are generally used as a fastening devices, or we can say a temporary fastening devices, which can be assembled and disassembled. But as far as power screws are concerned, these are used for transmitting the power. So power screws are used to convert the rotary motion into the translatory motion. It is also known as a translational screws. Power screws receives power or it translates the power. Okay, so many devices it may receive the power or it translates the power. In most of the power screws, the nut has an axial motion against the resisting axial force while the screw rotates in its bearing. So, in most of the power screws, the nut has the axial motion against the resisting axial force. As you may have seen, we are having a lead screw in the machine, in the lathe machines. So, what in this lead screw, whatever that lead screw is there, that lead screw rotates, and on that lead screw, a carriage or the tool post is being assembled, and it can move from one place. Translational motion is provided with the help of this power screw, that is the lead screw. So in this, the nut has the axial motion against the resisting axial force while the screw rotates in its bearing. While in some screws, the screw rotates and moves axially against the resisting force while the nut is stationary. Means since there are the different arrangement provided with the power screw, in some type of power screws, the power screw rotates, and whatever the nut is there on that power screw, that translates on that power screw. So translational motion is imparted on the nut itself. While in another type of arrangement, the screw rotates and moves axially against the resisting force while the nut is stationary. And in other another types, the nut rotates while the screws moves axially with no rotation. So in screw there is no rotation but nut rotates. So there are the three type of arrangements which are possible with the power screw. As the name suggests, this is used for transmitting the power, and that's why this screws needs to be more stronger than our usual fastening devices. Examples, as I mentioned, that is it is used as a lead screw of the lathe. You can see over here we are having a lead screw, and this lead screw rotates. This lead screw rotates, and on this lead screw there is a tool post or the carriage, and as this lead screw rotates, this carriage is nothing but a one type of nut, and it can translate along the axis of the lead screw. So this is one of the example of the power screw. Then screw jack. Screw jack is another example. Here you can see whatever the body is there, that we can call as a nut, and then this whatever the screw is there, this can move in upward and the downward direction. So our axial translational motion is in the screw itself and not in the nut. So this is another example of the power screw, that is screw jack. Apart from that, we may have seen the testing machine, UTM machine. So in UTM machine, again there are the power screw, various type of presses. So power screw finds many applications in this type of machine: presses, testing machines, UTM machines, screw jacks, then our lathe machines. So these are the various examples. Now as far as power screws are concerned, what type of thread profiles must be there? Okay, so three types of thread profiles are used for the power screws. One of it is most regularly used is called as a square thread. You can see over here, this square thread is having a thread profile that is of square profile. Okay, so whatever the teeth are there, these are having the perfectly square type of profile, and that's why it is called as a square thread. P is nothing but the pitch, P is nothing but pitch, H is the depth, and P by 2 is nothing but we can say the thickness of the thread. So these square threads, these are adopted for the transmission of power in either direction. So if we use this square thread profile, then this power screws can be used to transmit the power in either direction. Okay, and it is having a very good efficiency of this type of screw is very good, or we can say the maximum of the three. Okay, and it is having minimum radial or bursting pressure on the nut. Whatever the force is transmitted, the bursting pressure transmitted on the nut is minimum with this type of square threads. But as we see, these threads are perfectly square and vertical walls are there. So because of that, these threads cannot be manufactured easily by the use of simple taps and dies. Okay, as we know, threads can be cut with the help of taps and dies, but this type of threads cannot be cut with the help of taps and dies, and we need to manufacture it on the lathe machine itself. So machining operation is needed and the manufacturing is comparatively difficult, we can say. Okay, and apart from that, as you can see, there are the perfect vertical walls. These threads are comparatively weaker in shear, so shearing effects or the shearing failure are there are the chances of shearing failure. So this type of screws are generally used in the screw jacks, presses, clamping, various clamping devices like that. So this square thread is having some advantages and some limitations. Advantages: maximum efficiency is very good, minimum radial or the bursting pressure on the nut, and it can be used to transmit the power in both the directions. But difficulty, the limitations, we can say it is difficult to manufacture and weaker in shear. Okay, so next type of screw threads which are used for in a power screw is a Acme thread. So now whatever the limitations of the power screw that it is difficult to manufacture, that is being overcome in the Acme thread. If you look at the profile, teeth profile, then you can see over here, now whatever the walls of the teeth are there, that are not perfectly vertical, but these are inclined by 29 degree. So here again the P pitch, then H is the depth of the thread, and as the walls are inclined by 29 degree, so this is a modification, we can say this is a modification of the square thread. But as we incline the walls, because of that its efficiency is being lowered or compromised somewhat, and that's why it is having a lower efficiency than the square thread. And because of this, it induce comparatively more bursting pressure on the nut. So bursting pressure induced on the nut, while power transmission is more in this type of Acme thread. So whatever the advantages of our square thread were there, that comes as the limitations of these Acme threads. But its advantage is that it is more strong in shear. If you look at this, if you look at this, you can see the thickness at the root of the teeth are being increased, and that's why it is more stronger in the shearing, and this can be cut by the dies. So manufacturing cost, or it can be easily manufactured. That is another advantage of the Acme thread. Okay, but it is having the lower efficiency, and obviously this type of threads can again be used to transmit the power in both the directions. So that is the Acme thread. And now types of screw threads which are used, the third type of screw profile which can be thread profile which can be used, that is called as the buttress thread. Now in this buttress thread, what is the one side is being vertical and another is kept as an inclined. So it is a combination of, we can say, Acme thread and the square thread, and that's why it is having the advantage of both, that is square thread and the Acme thread. So in the buttress thread, but this buttress thread, as it is having a one vertical and one inclined edge profile, so this is suitable when there is a large force is to be transmitted only one direction. So when a very large force is being applied only in one direction, then this type of threads are generally employed. So it is combines the higher efficiency of the square thread and ease of manufacturing of Acme thread. So it is having a comparatively higher efficiency than the Acme thread, and it can be manufactured with the help of dies, and that's why manufacturing is more. So we can say it is having a goods of both, that is the square thread and the Acme thread. But again, it is having the limitation, and limitation is that when the forces are acting in one direction is very large, then this only can be applied, while in another direction forces acting should be comparatively smaller. Okay, so this type of threads finds limited application in power transmission, so it's having a very limited application. So these are the three types of thread profiles which are generally used for um, uh, which are generally used in a power screws.